Jai Hind everyone, my name is Amrita Bhatnagar. I am from CSE department of Akgec Engineering College. Today I am going to explain about the main memory and memory connection. So in this lecture I have included these topics: introduction to main memory, RAM chip, ROM chip, memory address map, memory connection to CPU. So firstly we will understand what is the meaning of main memory. So main memory consists of two kinds of memory. First is the RAM and another one is the ROM. The full form of the RAM is random access memory, which is a volatile memory. So it have volatile content and are destroyed when power goes off. RAM can be static or dynamic. Static RAM stores binary information in flip-flops. So information stays as long as power is applied. Dynamic RAM stores information in form of electric charges applied to capacitors. Charge stored tend to a discharge with time. So this is known as a RAM. Second one is the ROM. ROM is the full form of ROM is read-only memory, which is a non-volatile memory. It stores programs that are permanently resident in the computer. So example of the ROM is Bootstrap Loader. Bootstrap Loader is a program to start computer software operating when power is turned on. Okay, so this program is stored in the ROM. So we have three types of ROM. PROM, the full form of PROM is programmable read-only memory. It allows user to load the required programs once. Faster and less expensive because they can be programmed directly by the user. EPROM, erasable programmable read-only memory. The contents of the memory can be erased and store new data into the memory. In this case, we have to erase whole information removed from the circuit for reprogramming and erasing done by exposing chip to ultraviolet rays. And last one is the electrically erasable programmable read-only memory. In this type of memory, the contents of a particular location can be changed without affecting the contents of other locations. So in the main memory, we have these two type of memory. RAM store the user data. Normally when we work on the particular computer, then we write the content on the RAM. And ROM is written by the manufacturer. It is written by the manufacturer at the time of manufacturing. So we cannot change the content of the data, the content of the ROM afterward. Now, next, the size of the main memory determined by the addressing scheme. For example, if 16-bit computer generates 16-bit addresses capable of addressing up to 2 raised power 16, which is equal to 64K memory location. What it means, if we have an address of 16-bit, what it means, we can locate 2 raised power 16 memory locations in the memory. So this is the number of words in the memory. So in this way we can find out the number of words in the main memory. For example, if we have 32-bit addresses, the total capacity will be 2 raised power 32, which is equal to 4G memory locations. So these are the number of location or number of words in the memory. The data transfer between main memory and the CPU takes place through two CPU registers. First one is the MAR. MAR for the memory address register, where we have address of the memory. So you can see in this diagram also, this is the CPU and this is the main memory, and we are sending the data or addresses from main memory to CPU. So you can see here MAR is a memory address register and MDR is a memory data register, where we store data. In this case, we store address and MDR stores data. For example, if the particular address is 16 bits, so this address will be stored in the MAR, and each particular word is of for example 12 bit, then the value of the MDR will be 12. So if the MAR is k bit long, then total addressable memory location will be 2 raised power k. If the MDR is n bit long, then n bit of data is transferred in the one memory cycle. Data transfer take place through address bus and database. So, a particular memory can be, the size of the memory can be defined like this: 16 into 4, where the 16 is the address lines and 4 are the number of bits in each word. So, 4 will, the size of the MDR will be 4 here, and the size of the MAR will be 16 here, because of this is the size of the memory. I have taken an example. Now, data transfer take place through address bus and data bus. So, we have here address bus and data bus, and the third one is the control bus. Controls lines read write memory function complete for coordinating data transfer. CPU needs to know when the desired memory function read or write has been completed. This line back to the CPU saying that the operation is complete is sometimes called memory function complete. So, this is a scenario of communication between the CPU and main memory. So, these all are the three buses which we use between the main memory and CPU, and the register from where the data will be transferred from the memory to CPU and CPU to memory. Okay. Now we will understand what is a RAM chip, how it works. One or more control input that select the chip only when required. So, we should understand, to understand the RAM chip, we should see this diagram. This is the diagram of RAM. So, this is firstly we should understand how this memory size is written. 120, here we have written 128 into 8, where 128 are the number of words and each word have 8 bits here. That is why the size of the RAM is 128 into 8. Now, so yeah, we can find out here how many number of address lines should be there. 128 can be written like 2 raised power 7. So, the address lines will be here 7. You can see here the 7 address lines will be here, and the data lines, because 8 each word have 8 bits. So, we have data lines of 8 bits here. So, in this way we can find out the number of address lines and data lines in the RAM. And control lines, we have 2 control lines here, because RAM can read and write both operations. This can perform read and write both. These 2 signals are showing the chip selection 1 and chip selection 2. So, we will have 2 chip selection lines here in the RAM, CS1 and CS2 bar. CS2 bar means CS2 bar will be activated when the value of CS2 bar will be 0. That is why it is known as a CS2 bar. So, firstly we will see, this is the table we should understand. The value of CS1 1 and CS2 bar should be 0 for the particular operation in the RAM, because CS1 through the CS1 this RAM chip will be selected, and CS2 bar is equal to 0 means we have selected RAM between the RAM and ROM. So, you can see here when the value of CS1 and CS2 bar is 0, then there will be no operation in the RAM chip, because we can give any value 1 or 0 in the read and write input, then there will be no output. The buses will be in the high impedance state. In the next case, when the value of CS1 is 0 and CS2 bar is 1, this is again a wrong combination. So, we don't, if we give the value, any value to read and write, there will be no operation. Next one is the 1 and 0. This is the right combination of the chip selection. Now, the chip is selected, but there is no input from the read and write. That is why again this is the high impedance state of the buses. Next, the value is 1 and 0, and you can see here the write operation is going to perform, because the value of the write operation is 1 here. That is why input data to the RAM. So, write operation will be performed in the RAM in this way. Next, in the case of 1, 0 is the value of CS1 and CS2 bar, and the read operation going to perform, because this is the one, and write operation is cross. Cross means if the read operation is 1, then write operation cannot be considered, because the high priority operation is read. So, if the value of read is 1, then there is no way to give write operation. If the value of write is 1 or 0, it is known as a don't care condition. We will always perform read operation here. So, this is a read operation, and in the last case, when the combination again wrong combination is there, CS1 and CS2 bar is 1, 1, there will be no operation in the RAM. So, this is a table of the RAM chip. Now, the next Next is the ROM chip. So you can see this is like the RAM chip, but we have different size of the memory here, 512 into 8, where 512 is the number of words here. So, 512 can be written 2 raised power 9. So that's why we have 9 address lines here and 8 data bits into the data bus, because the word size is 8 bits. So we have 8-bit data bus here. We don't have here control lines because we in the ROM chip only the read operation can be performed. There is no need to two other different signals here for read and write, because only one action is performed here, that is read only. And next is the CS1 and CS2 bar are the two chip selection lines. CS1 is used for the selection of the particular ROM chip, and CS2 bar is used for the selection of the ROM chip between the RAM and ROM. Okay, again this is the CS2 bar. Now the address memory map. For example, now we have to see that if we want to create a memory of 512 into 8 RAM and 512 into 8 ROM chip. So we have only 128. You can see here we have only 16 bits here. Okay, so only in this case only 10 will be utilized and 6 are the assigned 0, because these all are the these are the unused lines are known as a. So you can see here in this diagram, is this table, you can see here we are using 10 address lines here. For the RAM we have 4 RAMs, because the size of the 120 RAM chip is 128. That's why we required for the 512 we require 4 RAM chips and only one ROM chip, because the size of the ROM is again 512, but the one ROM size is 112. So we are using only one ROM chip here. So you can see here RAM 1, RAM 2, RAM 3, 4 RAM chips are there, and you can see here this is the 10 address lines here, where we see the 1 to 7 we have a cross in the address lines, because these all are the common address line. When we have 128 size of a particular memory chip size, then you can write down is like 2 raised to 7. So 7 are the common lines in this RAM. And next 8 and 9 bit is used for the chip selection, because we have 4 RAM, so only one RAM will be selected at a time. So we need 2:4 decoder here. So we will apply 2:4 decoder on the 8 and 9th bit, so that we can find out the which RAM chip will be selected here. So you can see here 7 are the common lines and 8 and 9 are the 0, 0, 0, 1, 1, 0, 1, 1. Different combination are you can see here. In the case of RAM, because we have only one chip, so there is no need of chip selection lines here. Only one chip selection line 10th will be used here, which is used for the RAM or ROM. Here you can see here RAM is selected and ROM is not selected, because we are using here CS2 bar. So it is activated when the value of 0. So here the value of 0, 10th bit is 0 for the RAM. So RAM is selected in this case, and this 10th bit will be used for the selection between the RAM and ROM. But we have only one ROM chip, that's why we have no other chip selection lines here. So you can see here we have 9 common lines, because the size of the ROM is 512. So 2 raised to 9 we can write and we can find out the address lines here. So you can see here 9 address lines will be, common lines will be here. So in this way we can draw the memory address map also. So this is known as a memory address map, where we will define each and every address, and after that we have 6 another unused address lines is also, which are not used. If the memory size we increase, then this lines also can be used. Now you can see here this is the memory connection to the CPU. This memory which we have defined here, we are going to connect with the CPU here. So you can see here we have RAM 1, RAM 2, RAM 3 and RAM 4, which we have already discussed in the previous slide also. CPU has 16 lines, but 10 lines are used in this case in the memory connection, and 6 lines are unused here. So we have 4 RAMs and only one ROM, and the size of one RAM is 112 into 8. So Now what is happening here, you can see here that this is the data bus and the size of data bus will be 8 here because the each and every chip have 8 bits of particular memory word. So this, you can see here, this data bus is connected and the size of the data bus will be 8 bits. Now you can see here we have CS1 and CS2 bar. Here the CS1 is used for the selection of the chip between the RAM 1, RAM 2, RAM 3, RAM 4. So if the value of decoder, you can see here 8 and 9 bit is used for the decoding or to find out the RAM between these 4 RAMs. If the value of 0, 0, 8, 9 bit is 0, 0, so the output of the decoder 0 will be 1 here. So you can see here the RAM 1 will be selected. If the value of 8, 9 bit is 0, 1, then RAM 2 will be selected. If the value of 8, 9 bit is 1, 0, then RAM 3 will be selected. If the value of 8, 9 bit is 1, 1, then the RAM 4 will be selected. In this way, the 8 and 9 bits will be working here. And 1 to 7 bits are the common bus lines here in the RAM, because we have the size of 128, which can be write down 2 raised power 7 here. So 7 bits are the 7 lines are the common lines. So you can see here these 7 lines are connected to each and every RAM. And the another bits are the control lines, which we have already discussed, which are known as a read and write, because in the RAM only we are using this read and write, because we can perform read and write both operation in the RAM. Now you can see here for the ROM chip, you can see here the 9 address lines are used for the common lines, and one CS1 is use only one, and which is connected to read only, because there is no need of CS1 because we have only one ROM chip here. If we have more than one ROM chip, then only we can use decoder or we can use more address lines for the CS1 or for the particular RAM selection. Here we are using only one CS2 bar address lines to select the between the RAM and ROM. So in this time, if the value of CS2 bar of ROM is 0, then this ROM will be selected. And we don't have here a control line read and write, because we can only perform here read operation. And you can see here this is the data bus, which is again here 8 bits, which is connected 8 bits, because the size of the ROM is also 512 into 8, where 8 is the number of bits in each and every word. So in this way, we can connect these memories to the CPU. This is known as a memory connection to the CPU. So this is the particular example of the connection between the CPU and memory, where we have number of RAM and ROM chip. So in this way, we can connect these type of RAM and ROM to the CPU. Okay, I think you have understand it better. Thank you.